This is Math Analysis, Blitzer Pre-Calculus 4th edition, checking section 1.8 homework. You can see the assignment there on the page, and I ask you to please go to the back of the book and check the odd problems. So you can pause this and check the odd problems. I'll meet you on the next page. Okay, here from page 240, you can see those even problems in that assignment. And you can pause and check this group. And in a moment, I'm going to move on to the next page. But looking at number 6, you were asked to find the f of g of x and then find g of f of x. And so when you did the two, if you look at the results, those are really, really close. 3x minus 40 over 7 and 3x minus 4 over 7. But they have to be identical to be inverses. So since those are not perfectly identical, they are not inverses of one another. That's how you check if two functions are inverses. Plug one into the first one in the second and the second one into the first, and the results should be identical. Otherwise, they are not inverses. You can look through the rest of those and pause it if you need to. I'm about to turn the page. There we go. And here there's 42 again, and then the 48. You can see the graphs. And by the way, this part was the answer. Okay, not being nice. Sorry, we'll try this again. Okay, one more time. Thank you. Okay, that's the solution to that question. So hopefully you've seen the domain and range, and notice here how if written, the domain of f equals the range of f inverse, and then the range of f equals the domain of f inverse. Those two totally switch, and so you can write it like that and only have to write it one time. We'll do that in a problem in a moment. I'm going to work a couple of these for you. The most asked for problems were 18, 27, and 42, so we're going to work those. Okay, so here's problem 18. And the directions here ask you to find the inverse, and that's the main thing I'm just going to do. Let's practice finding the inverse. What are the steps? The first thing we're going to do is change that f of x into a y. So now we have x and a y in the equation. And the next one, what we should do next is trade the x's and the y's. They just completely change places. Okay, that's an equal sign. And now we're going to solve for y. So we will add 1 to both sides. And I've got a cube. Y cubed. How do I undo a cube? Well, to undo a cube, I take a cube root. So that will be the cube root of x plus 1 equals y. And now we'll take that y and turn it into f inverse of x, and f inverse of x is the cube root of x plus 1. Okay? So there's number 18. And now let's look at 27. Again, here you are finding the inverse. So we will put y where f of x is, minus 3, sorry. And then we will trade the x and y. So that y becomes an x, and now here's a y, here's an x, so that's now 2y plus 1. This is now y minus 3, and here's a problem. I've got y in two different places. So what will we do? Well, I'm going to look at this. Since the right-hand side is a fraction, I'm going to treat the left-hand side as if it's a fraction also. And now I have a proportion. I'm going to cross multiply and get the results. So it's x times the quantity y minus 3 equals 2y plus 1. Well, there's a parenthesis, so let's get rid of that by distributing. So I have xy minus 3x equals the 2y plus 1. What am I doing? I'm solving for what? Solving for y. So I need all my y's together. So I'm going to move the y, this xy term to the other side and bring that 1 to the left. So I have 1 minus 3x equals 2y minus xy. Okay, is everybody good with that? Now I have both y terms on the right. I still have two y's though. I need a y in only one location. So I'm going to factor out that y and get 2 minus x. So now y is only in one place. That equals 1 minus 3x. And now I will divide by the parentheses. So let's move over here. And I have y is equal to 1 minus 3x over 2 minus x. So f inverse of x is 1 minus 3x over 2 minus x. Now, it's possible you took things to the other side, and so you could have taken a negative out. I'm going to take another version of this would be 3x minus 1 over x minus 2. If you took things to the other side, it would have come out that way. Okay? All right, so either one of those versions is the same. And we're going to do one more. Number 42. Problem is f of x equals x squared minus 1, where x is less than or equal to 0. And we want to find the inverse. We want to graph both of them, and we want to find the domain and range for both of them. Okay, so let's start by finding the inverse. So y equals x squared minus 1. Trading x and y, I get x equals y squared minus 1. Now we're going to move the 1 to the other side. So I have x plus 1 equals y squared. And I'm solving for y, so I'm going to take the square root of both sides. Now, I'm going to switch sides as I'm doing it. Y equals, and the square root of this, yes, there'll be a positive and a negative, okay? But we have a domain up here that's going to determine which part of that, the plus or the minus piece we use. So I know it seems weird. I've told you about it's got to be a square plus and minus if you're taking the square root of both sides. But since this is a restricted domain, we will figure out which part as we graph the first portion. Okay, so it's going to be one of those parts. So f inverse of x is the square root of x plus 1. I think. Here we go. Now, let's graph. If we're graphing x squared minus 1, that's a parabola that has moved down 1 unit. So here it is, and then here are my points over 1. That was not pretty, I'm sorry. And over 2 up 4. So we have, this is essentially our parabola, but the domain right here tells me I only want the part that where x is less than or equal to 0. So that means I only want the left-hand part of this. So I start here, and I have that portion. Okay? So I'm going to move out all that blue stuff. Maybe. Some of it anyway. And there is the first graph. Now, how do I graph the inverse of a function? Well, remember, here's our line y equals x, and I'm going to flip it over that line. So if this point is, the vertex of that parabola is at negative 0, negative 1, 0, 0, negative 1, then the inverse is going to be negative 1, 0. So negative 1, 0 is here. And then it passes through the point, the green one passes through the point negative 1, 0. So that means this one's going to pass through the point 0, 1. So we see this is going to end up coming this way right here. Okay, so it almost looks like a continuous piece. Now the question is, which part, looking at what I just graphed in black, is that the positive, looking over here, is that the positive or the negative version? It's below, so that's the negative part. So because of the domain restrictions for the original, it gives me the restriction for my actual inverse. So it's the negative part. Okay, so that's the function that is the inverse, the one with the negative. And now I need domain and range. So the domain of the original is this that's in the circle right here. There's the domain of the original. So my original domain of f, which is going to be the range of f inverse, okay, there's that trick, then it's from negative infinity to 0, right? Negative infinity to 0, including 0? Yes, it includes 0. Now, I need the range of f, which will be the domain of f inverse. I don't have to think about the other one. They swap. Okay? So, the range of the green started down at negative 1, right? And it went up to positive infinity. So, negative 1 to positive infinity, and this is included and not. And then let's just double check. The domain of the black domain, does it start at negative 1 and go to positive infinity? Well, here's the negative 1, and it goes to positive infinity. So yes, that worked. Does the range start at negative infinity, which is down, and go all the way up to 0? Well, yes, I can see I'm down. It's down and moving up, and it doesn't go any higher than 0. So there we have it. That's how that one's worked. I hope you were listening, because you might see that again. Okay, so there are 4 points apiece. You can put a grade on your paper. This was checking section 1.8 inverse function homework.